In this video, I'm gonna go over some transformations with exponential graphs. Okay, so previously in chapter 1, we already came across different types of transformations. We covered translations, moving the graph left and right, up and down, and then we also came across reflections across the y-axis and across the x-axis. We also have compression and stretch. So we have horizontal compression and stretch, vertical compression and stretch. In this video, I will be going over translations and reflections. Okay, so let's get started. Right now, on the screen that you see, we have an orange curve, an orange color curve, and that is my y is equal to 2x. Okay, y is equal to 2x. Now, if my x is equal to 1, and I put that in my y is equal to 2x, then my y value will be 2. So this point, 1, 2, is on my orange graph. Okay. Now, as we already learned about transformations in chapter 1, so this will be more like a review, okay? And we're just gonna apply the same knowledge. So feel free to take out your notes on transformations. We're gonna apply the same knowledge to exponential curves. So let's look at this. Here I have y equals 2 to the power of x plus 3. All right. So this equation, what we have done was we added a plus 3 to the x, right? We added a 3 to the x, then we have translation. All right, so look at your notes, the translation part. If you add a 3 to the x, then is the graph now gonna be the new graph? When I show this, y is equal to 2 to the power of x plus 3 as the exponents. When I show that graph, do you think it's going to be on the left of the orange graph, or is it going to be on the right of the orange graph? I hope your answer is to the left. So in other words, this 1, 2 would now, where is it going to be? The 1, 2, I'm going to move it to the left by 3 units. So that would be at -2 and then 2. And let's see if we get that right. Yay. Okay. So when we have y is equal to 2 to the power of x plus 3, we moved the whole entire original graph, the orange one, we move it to the left by 3 units because we're adding a 3 to the x and the x only. So now if I try to say, I want to move it to the right, then all I have to do, let's say move it to the right by 5 units. So I just have to subtract a 5 from the x. And you can see that my graph, well, from 1, 2, now it's going to be 1, 2, 3, 4, 5. It will be at 6, 6, 2. Okay. All right, cool. Now, this is horizontal translation. Nothing new. Now, if we have the next one, let's say vertical translation. So when we have vertical translation, we're adding a value to the entire function. So here I have 2 to the power of x, which is the original equation that I have here. I'm just going to add a 3. So that will, what is that gonna? We know that this is going to be vertical translation. And then what do you think will the new location of this 1, 2, this point 1, 2, where is that going to be now? It should be at, is the x going to change? I hope your answer is no. The x is not going to change, but we are going to move the graph up by 3 because of this plus 3. So the y value is going to change. It was 2, so if you go 3 up, then you'll be at 5. Okay, and I'm going to show the graph, and hopefully it's gonna pass through 1, 5, and it does. Okay, so we have carried out the transformation to this point correctly. So if I say if I want to move 3 down, all I have to do is to change that sign and change that to negative. Then it's gonna go from 1, 2, so to go down 3 units, 1, 2, 3. So it's gonna be here. Right? It is now at 1 and negative 1, 1 and negative 1. Okay. All right. Lastly, for this video, I'll wrap up this video with reflections, which we already mentioned about it just now in the previous video. So here I have y is equal to 2 to the power of negative x. Let me remove the stuff that we already did. Okay, so now we're talking about y is equal to 2 to the power of, in the exponents I have negative x. Cool. We are multiplying a negative to the x, and we mentioned about this in the previous video. So here, when we're multiplying negative to the x only, we have horizontal reflection. We have horizontal reflection. So if I show the graph here, if I show it, I should see the exact same curve, but reflected across the y-axis, right? So, and the blue is the new line, and you can see that because I'm reflecting across the y-axis, the point 1, 2 is now, it has just became negative 1 and 2. Okay, because it's a reflection across the y-axis. Now we also mentioned this in the previous video. Now this is horizontal reflection. Let's talk about vertical reflection. If it's a vertical reflection, in other words, I'm going to reflect this orange line across the x-axis, so I'm gonna sort of turn it upside down. And in terms of the equation, what I do is I would have a negative in front, right? I will have a negative in front of the original equation, right? And that will turn everything upside down. So this 1, 2 will be, since if I reflect this across the x-axis, the x value is going to stay the same, right? But the y value will change. So this point 1, 2 now is going to become 1 and negative 2. And I'm going to show my graph y is equal to negative 2 to the power of x, and hopefully it will pass through the point. And yes, it does. So for now we have a horizontal reflection because we have a negative sign in front of the entire equation, the original equation, and that will give us a vertical reflection. In the next video, I'll be talking about compression and stretch, horizontal compression stretch, vertical compression stretch. Please make sure that you are comfortable with translations and reflections before watching the next video. Alright, see ya.